guys. Today we will be looking at the geometry of straight lines, and here we just have an index for what the following few lessons will be about. Lesson 1 will be about the theory, terminology, naming of an angle and classifying an angle. Lesson number 2 or video number 2 will be straight lines, angles in a straight line, vertically opposite angles, and angles around a point. Video number 3 will be about parallel lines, corresponding angles, co-interior angles, and alternate angles. And then lesson number 4 or video number 4 will be mixed questions where we apply all the theorems that we've just learned. So let's start off with the theory of the geometry of straight lines. And the first thing that we're going to look at is some terminology, just so that when we speak about certain things, you are comfortable with the words that we are using. So we're going to start off by drawing 3 lines with a point, and here we have A, B, C, and D. Point B, point B is the vertex. We call it the vertex. We will speak about BC now. BD, we will call line BD, and then AB, we will call line AB, and you will see that all that we do to name the line is just stating the end point or the beginning point and the end point, and it doesn't matter in which order you name it. It can be AB or BA. Both of them refers to the same line. And then if we look at line CB or BC that's been highlighted, that we call the common line. So that means that it's a line that's shared between two different angles. And now let's look at naming the angles. So we're going to start off with an angle here, and we see we have a vertex F, and then we have line EF, and then we have line FG. And when we name an angle, we are either going to call this angle F, because this angle is subtended by the two lines, to the line EF and GF, so we can call it angle F, or we can write it with a copy, so to say that also indicates an angle, and the angle is at the vertex F, or we can name it EFG, angle EFG, with the accent being on the F, stating that that's where my angle is, at vertex F. Or we can name it from the other side, saying that it's GFE, again with the angle at F, because of the vertex at F. So we can also have it in a different way. So say, for instance, now we have two angles between 3 different lines. So we've got vertex H, then we've got line IH, line JH, and line KH. But now we've got 2 different angles. And now if we have to specify a part of an angle, we have to say we can't just call this angle H like we did in the previous one, because we are looking at just one part of an angle, so a certain section of an angle. So in this case we are either going to call it IHJ, angle IHJ, with H being the vertex, but going from subtended between the line IH and JH. Or we can name it other way around, saying that it's angle JHI. So those are the only 2 ways that you can name that angle. And say, for instance, another way of indicating angles is they might say, but the other side of this angle is now called angle H1, or they make a small subscript 1, and then we can call it angle H1 with a subscript 1. So referring to that part of the angle that's subtended by JH and KH. So be careful when we name angles. If it's the whole angle, then you can call it angle F, like in the previous case, in case number 1. But if it's case number 2, where we are referring to a part of an angle, you have to specify between which 2 lines those angle that angle lies, and therefore you have to specify, okay, is it IHJ or is it going to be JHK, depending on which angle you are referring to. So just a quick testing your knowledge. So name the following angles for me. And I'm going to give you 3 angles that we're going to name. So the first one here is we've got vertex B, we've got line AB and line BC, and we want to name that X, that angle X. What will be the name of angle X? And because we see that it's the whole angle, we can either say it's angle B, or we can say it's angle ABC with the accent being on the B, or we can say it's angle CBA. Did you get that right? Okay, let's look at number 2. Here we've got a vertex of G, we've got 3 lines, DG, GF, and GE, and we want to determine what the name is of angle Y and angle Z. So now remember, because we don't have a whole angle, we can't say it's angle G, because angle G refers to Y and Z combined, actually, the whole angle G. So we have to specify between which 2 lines we are working, so which 2 lines obtains that angle. So for angle Y, we're going to either call it angle DGF, with the accent being on G, or we can say it's angle FGD with the accent being on G, and for angle Z we're going to say it's FGE with the accent on G, or it's angle EGF with the accent on G. Let's go on to the next slide. So now we are going to look at classifying angles. Now I know that you might have done this a lot at primary school, but this is just a refresher course. So let's look at the first one. So we've got our compass here, protractor. We've got our protractor here, and we see that the first angle is 60 degrees. So we measure 60 degrees. Now because this angle is smaller than 90 degrees, so we write it out in words, angle is smaller than 90, and you will see that symbol represents the word angle, so we can replace the word angle with that symbol. And then if we have to write it mathematically, we're going to just say the angle is smaller than 90 degrees. So remember your smaller than and bigger than signs. So this is my smaller than sign, and this we call an acute angle. So an angle is smaller than 90, we call it acute. Let's look at the next one. So the next one is 120 degrees, so we measure it from 0 in an anti-clockwise manner, and we see that it's 120 degrees, and because this angle is between 90 degrees and 180 degrees, so we wrote it out there, angle between 90 and 180, we can write it mathematically with the angle being in the middle, and then we go to the left, reading it that the angle is bigger than 90, so we start with the unknown variable, which is the angle. We read it to the left, angle bigger than 90 degrees, and then we start with the angle again and we read it to the right, angle smaller than 180. And because it's written in this way, we can read it as follows in words. It's going to be that my angle is greater than 90 degrees and my angle is smaller than 180 degrees. And this then we call an obtuse angle. If the angle is between 90 degrees and 180 degrees, and in this case you can see that it's not equal to 90 degrees and it's not equal to 180, but it's between 90 and 180 degrees. Now the next one we're going to be looking at is the 220 degrees. Say for instance we measure this angle and we see that this angle is between 180 and 360 degrees. So we write it out in words, and to write it mathematically, we're going to start with the angle in the middle, read it to the left, angle bigger than 180 degrees, and read it to the right, angle smaller than 360 degrees. or we can say that the angle is between 180 and 360, and this we call a reflex angle. And then the last one that we're going to be looking at is this case where it's equal to 360 degrees. So when the angle equals to 360, we can write it mathematically as just saying the angle is equal to 360, and this we call a revolution. Two that I did not mention on this slide was actually the 90 and the 180. So we know that the angle, if the angle is equal to 90 degrees, we call that a right angle. And when the angle is equal to 180 degrees, we call that a straight angle. So just two for you to maybe include that I haven't included here. Now, if we look at further classifying angles, so here we've got two angles, angle X and angle Y. And these two angles, because they are on the same straight line, and they are just separated by one line between them, we call these two angles adjacent. And the adjacent angles means that they are next to each other. So they lie on the same straight line, they are next to each other, placed next to each other. But we can also say that these two angles, X and Y, are supplementary. And supplementary simply means that they add up to 180. So if we look at X and Y together, then it forms a straight line. So we say they add up to 180 degrees, and therefore we call them supplementary angles. They are supplementary angles. And if I look at the following two angles, M and N, that's also separated by a line, but they add up to 90 degrees. So if we have two angles that add up to 90 degrees, we call them complementary angles. So complementary angles are angles that add up to 90 degrees. So whenever we have angles adding up to 180 degrees, we call those supplementary angles. And when they add up to 90 degrees, we call them complementary angles. And it's just important to notice that do not just assume that that angle is going to be 90 degrees. So don't just assume it's going to be a 90 degree angle. We're actually looking for a specific symbol that tells us that it's 90 degrees. And the symbol that we are looking for is that block. That block actually tells us that that angle is equal to 90 degrees. So don't just think because you see two lines and it looks like they are at a 90 degree angle that it's going to be 90 degrees. You have to look specifically for that block symbol to indicate that it's equal to 90 degrees. Okay, and then just lastly, I have a exercise here for you to do, so you can take a few minutes and do that exercise and pause the video, and then I'm going to give you the solution just now. Okay, so here's the answers. So for the first answer, we would have said that it's an acute angle. If they gave us that block, we would have said it's a right angle. Second one is an acute angle. Third one is an obtuse angle. Fourth one is a reflex angle. Then we have an acute angle, or if they give us the 90 degree block, we would say it's a right angle. Then it's another acute angle. This we call a straight angle because it's equal to 180 degrees. Then we've got another reflex angle, and lastly we've got an obtuse angle. Okay, that's all for this video. Thank you.